Hello everyone, today we are going to discuss a question of gate 21, and this question is of metric space. We have to only check that D1 and D2 given as uh, is metric on open interval 0 1 or not. So for this we have to know only definition of metric. So by first property we have to say d of xy is greater than or equals to 0 or not. So clearly this is always positive because this is modulus of something. So property number one is obviously satisfied for this d1 and d2 also, because this is also modulus of something or zero. So for property number two, which says that d of xy is equals to 0 if and only if x equals to y. For this, consider d1 of xy is equals to 0. So from this, if and only if modulus of ln x by y is equals to 0, if and only if ln x by y is equals to 0, if and only if ln x minus ln y is equals to 0, ln x equals to ln y, this x equals to y. Why? Because log is an increasing function, strictly increasing function. So property number 2 is obviously satisfied for d1. Now for property number 3 is symmetricity. For this we consider d1 of xy is equals to modulus ln x by y. We can write it like as minus ln y by x. This is equals to ln y by x modulus, which is d1 of y by x. So symmetricity property is obviously satisfied. Now fourth property is triangle inequality. For this we consider d1 of xy, which is ln x by y. We can write ln x minus ln y. We can add and subtract ln z, ln x minus ln z plus ln z minus ln y. Now we know that modulus of a plus b is less than or equal to modulus a plus modulus b for any positive quantity a and b. For any a and b belongs to real number. Now ln we are taking this as a and this as b, so we got less than or equals to modulus ln x minus ln z plus ln z minus ln y. So this is less than or equals to d of x d1 of xz plus d1 of z y. So triangle inequality is also satisfied for this. So we can say that d1 is metric on this interval. Now for d2, it is obvious that first property is obviously satisfied. Now for second property, if d2 of xy is equals to 0, if and only if x equals to y. So this second property is directly satisfied from the definition, so we don't have to check second property. For symmetricity, if d2 of xy is equals to 0, then obviously x equals to y. This implies x equals to y, so d of yx will also be 0 because x equals to y. So in this case, third property of symmetricity is also satisfied. And now if d2 of xy is non-zero, means x is not equals to y, so we got mod x plus mod y. So we can write mod y plus mod x. We can write d of yx. So in this case, symmetricity property is also satisfied. So third property of symmetricity is obviously satisfied in this. Now we have to check only triangle inequality for D2 metric. For this we have to consider two cases. Case number one, when consider D2 of xy. Triangle property for this, what is triangle property for D2? It is d2 of xy should be less than or equals to d2 of xz plus d2 of zy. So for case 1, let us suppose that x equals to y, and the z you are considering is equals to x and y. So for this case, uh, for this case, this is equals to 0, this also 0, this also 0. Because why? Because x equals to y is equals to z. So for this case, triangle property is satisfied. Now let us suppose that x equals to y, but z is not equals to uh, x or y. So in this case, this is equals to 0 and this is not equals to 0 and this is also not equals to 0. It means that this is some positive quantity, and this is 0, so obviously this is greater than or equals to 0. So triangle property is satisfied in this case also. Now case 2, when x is not equals to y. So if x is not equals to y, then d of x y is equals to mod x plus mod y. So we can clearly see mod x plus mod y uh, plus mod z plus mod z. We are adding something in this. So this is less than or equals to mod x plus mod z plus mod y plus mod z. So this is d of xz and this is d of yz or zy. So d2 of, so clearly triangle property is satisfied for d2 also. So what we get, d2 is also a metric on 0 1. So which option will be correct? This option a. Both a and b are both p and q are true, means d1 and d2 both are metric on this open interval 0 1. Thank you.